For section 10.5, we are going to be solving equations with exponents. So we're going to jump right into examples, and we need to figure out what x is here in this problem. So the first thing that we're going to do is get rid of that 5 halves. So we're going to divide by 5 halves. Dividing by 5 halves is the same as multiplying by 2/5. So we have 2 to the x power here, and 80 times 2/5 is 32. So then we kind of have to guess and check. 2 to the what power? So how many 2's multiplied together gives us 32? And that would be 5. So 2 times 2 times 2 times 2 times 2 is 32. So x equals 5 because 2 to the 5th power equals 32. And for this one, we are going to have to divide by 4 first. So we're going to be left with 5/3 to the x power equals, and dividing by 4 is finding out what 1/4 of 527 is, and that would be 125/27. And then we have to guess and check. How many 5's does it take to get to 125, and how many 3's does it take to get to 27? And the answer needs to be the same. So 5 times 5 times 5 is 125, and 3 times 3 times 3 is 27. So it's 5/3 to the 3rd power. So x equals 3. So 5 to the 5th equals 125, not to the 5th, to the 3rd. And 3 to the 3rd equals 27. So that's how x equals 3. Now, example 2, we're going to use a graphing calculator for. And it says a town has 78,918 residents. The population is increasing at a rate of 6% per year. The town council is offering a prize for the best prediction of how long it will take for the population to reach 100,000. Make a prediction. So step number 1, they want us to write an exponential model to represent this situation. So we have y equals our starting value, and that's supposed to be a comma, is 78,918. It's an increase, it's growing. So we have plus 6% as a decimal is 0.06, and then to the x power. So that is our model here. Then step 2 wants us to write an equation in one variable to represent the time x when the population reaches 100,000. So what that means is, when does it equal 100,000? So instead of having a y, we're going to have 100,000. Oops. And if I add those together, I get 1.06 to the x power. So when will it equal 100,000? Then step 3 says write the functions for the expressions on either side of the equation. So we have to break it into 2 equations. So we have 1 equals 100,000 and 1 equals 78,918 times 1.06 to the x power. So we have 2 equations now. And then step 4 is to graph these functions on a graphing calculator, letting y1 equal f of x and y2 be g of x. And then they told us what to change our window to, and our scale, and then sketch our graphs. So I have graphed these here on our Desmos graphing calculator, and this is what we have zoomed into the window given. And the question is asking us, to use the intersect feature on the calc menu to find the input value where the graphs intersect. Do not round more than the calculator has already done. So in the graphing calculator in the classroom, we can use calc and then hit where it says intersect. But here I have to click on the screen where they intersect, and it shows me that the x value is 4.063. So we're going to write that down. X equals 4.063. And then step 6 is to use that input value to make a prediction as to the number of years the population reaches 100,000. So 4.063 is very close to 4 years. So right around 4 years, the population of this town will have increased to 100,000 people.